Good morning, everyone. For Atmanirbhar Bharat workshop, I am talking about how local resources can be used for water management. So, my presentation talks about water management in the city of Bangalore. So, local resources for better water management. Urbanization has brought about many positive and negative changes to the society and nature. Among these many negative consequences of urbanization, disappearance of ponds and lakes and depletion of groundwater can be regarded as a very severe consequence. This has not only depleted groundwater but also has led to water transportation from great distances to the majority of cities. This condition is not only in India but can be observed in many cities of the world. This has resulted in ecological imbalance like increase in urban heat island and tapping water from deep aquifers through bore wells, which has depleted and overexploited the groundwater condition. Bengaluru also underwent similar kind of changes, which observed a rapid urbanization and changed the terrain of the city. This rapid growth happened from 1971 to 2011 when many of the industries were established. And so we see that many water bodies disappeared and there was loss of vegetation and over exploitation of aquifer water. So the terrain which was barren initially, it was transformed to become a land of full of water bodies. But later, due to urbanization, again it lost majority of its water bodies. So when we see due to industrialization, the spatial development of the city, during the establishment of public sector industries, the city started growing towards the location of these industries. Though there were many industries earlier to the establishment of public sector industries, that did not change the spatial development of the city. But 1973 onwards, we see that due to the location of public sector industries, the spatial development also changed that of the city of Bangalore. So when we trace such the development during the 1990s, when small scale industries came up, again the city started growing towards the location of these small scale industries. Very rapid growth can be seen during the development of IT industries, which are located mainly in the eastern and southeastern direction of the city. So during 2014, we can see that the city had rapidly grown towards the eastern and southeastern direction of the city. And this growth exceeded even the urban boundaries, where this is CDP boundary or master plan boundary. We see towards the southeastern direction, it has grown beyond this the CDP boundary. Similarly, we see the BBMP boundary also is not covering the growth that has happened towards the southeastern direction. City is gradually growing out of BBMP boundary also. So the city, when it started growing, earlier the water supply was from lakes and ponds. When industries were developed and population became more, they had to think of a perennial source of water supply. So Arkavati River, which was flowing very close to the city, was tapped near Hesarghatta. A reservoir was built here and the water was supplied from there to the city. Then, as the industries increased and urbanization happened more, they had to construct another reservoir across the same river Arkavati near TG Halli, and both these reservoirs were supplying water to the city. Further, many industries were developed and urbanization increased, population increased, demand for water increased. So they had to think of tapping Kaveri water and bring water, pump water from there. The river Kaveri, it flows around 100 kilometers from the city and it is deep down in the valley, and so the water had to be pumped for a height of 500 meters. When Kaveri water was commissioned for the first time, water was still supplied from Hesarghatta and Tippagondanhalli reservoir. So Kaveri water was supplied only towards the southern part of the city. The two reservoirs, Hesarghatta and Tippagondanhalli, supplied water from to northern, eastern and western part of the city. So Kaveri water, first and second stage, both supplied water to the southern portion of the city. Later, when the yield from both Hesarghatta and Tippagondanhalli gradually started reducing, Kaveri third stage water supply was commissioned, and it started, the supply was given to the central part of the city. Further, over some time, the water from Hesarghatta and Tippagondanhalli almost stopped. So, Kaveri water supply fourth stage was commissioned in 2008 and 2012. It was commissioned in two phases, and that supplied water to the peripheral areas of the city. The supply was given to Electronic City and also to the International Airport in the north. So this supply was only covering a portion of the city, but later when BBMP expanded, BWSSP also tried providing water supply to the major part of the BBMP areas. But when since water had to be pumped from southern direction to the northern direction, since it had to be pumped for a very long distance, a lot of electrical energy was consumed in the process. So it is a well-known fact that horizontal pumping consumes more electrical energy than vertical pumping. But since the distance had to be covered, a long distance had to be covered, lot of electrical energy had to be consumed for supply of water. So BWSSP spends around 75% of its revenue for paying electrical bills. It's not only this, but the groundwater condition also depleted. Since many areas of the city did not get Kaveri water, the others had to depend on groundwater supply. So this also depleted over a period of 40 years to the level of 10%. Though Kaveri fourth stage water supply was given, even then groundwater started depleting. So what is the solution? What can be the local solution for these problems? Urbanization and growth of the city cannot be controlled. Water supply has to be given to everyone. So now, recently, many of the researchers are coming up with some concepts of solving this problem. One such concept is bioretention basins, where they think of reviving urban watersheds by means of this local low impact development design. That is, does not impact the ecology to a large extent, but they are very easy to construct also. So these are known as bioretention basins, which are said to reset the hydrological flow paths. So these are basically very shallow ponds with water retention capacity. That is, for a short time, water is retained in these basins and slowly they infiltrate into the ground. So they are constructed near the street side tree plots. So where the trees are there, near that these basins can be constructed, and so the storm water runoff from these streets, that is the impervious area, can get collected in these shallow ponds, and also water from rainfall, that is precipitation, also get collected in the bioretention basins. Thereby, stormwater runoff can be controlled, and even flooding can be controlled. So these also have other advantages, like they reduce urban heat island. and also reduce ambient temperatures through evaporative cooling. That is, since trees absorb a lot of water, they reduce ambient temperature and also reduce urban heat island effect. So these are some of the examples how these bioretention basins can be constructed. So this is the impervious surface, and a slope and an opening is made so that the water gets collected in these basins. And here a gradual slope is provided towards one side, and after some time the water can slowly infiltrate into the ground and thereby improve the groundwater condition. And also there are other methods where these kind of basins can be constructed, where the water is made to stagnate in between the trees. So this is known as rain garden. So the water is it stagnates for some time, and very slowly it infiltrates through many layers of filters, and this water can be collected in a pipe, and the water can be led to a tank. The water from here can be pumped out to be used or supplied for secondary use, or if the filtration is very pure, they can be used for drinking purposes also. Or this water can be led to any water bodies, river or a creek. So this also improves groundwater condition, or rainwater can be used for any other purposes like drinking or washing and cleaning purposes. So this kind of construction helps in controlling the heat or temperature of the cities also. So some solutions are like existing water bodies can be revived so that the groundwater level can be improved. Bioretention ponds can be proposed in open areas or parks wherever it is possible. And if existing water bodies can be used for other than drinking purposes, fresh water can be saved. That is, they can be used for cleaning and washing such purposes. So at least some amount of water, fresh water can be saved. Rainwater harvesting should be maximized either by collecting them on top of the buildings or in open areas like providing bioretention ponds. So these local resources or solutions, if they are developed, we can reduce the quantity of water that is being pumped from Kaveri River, and thereby reduce the energy consumption also. So such local resources should be used for reducing water that is transported from long distances. Thank you.